The wind on top of the mountain does not howl, it whispers. At an altitude of 4,200 meters, the air is thin and sharp. It tastes like ice and old stone. Here on the summit of Mauna Kea in Hawaii, the world below feels like a distant memory. The thick layer of clouds, which the locals call the Sea of Clouds, blocks out the lights from the cities on the island. Below that white blanket, people are sleeping, driving cars and watching television. But up here there is only the sky, the cold and the silence. It is the type of silence that feels heavy. It presses against your ears. It is not just the absence of noise, it is a physical presence. This is the architecture of silence built from thin air and ancient volcanic rock. In the center of this quiet world sits the W.M. Keck Observatory, specifically Keck 2. The giant white dome looks like a temple built for a god of glass and mirrors. Inside the dome, the telescope is awake. It is a massive machine weighing hundreds of tons, yet it moves with the grace of a dancer. It tracks the rotation of the Earth, fighting against the spin of the planet to keep its eye fixed on a single point in the deep dark. Inside the control room, Dr. Elias Thorne rubbed his eyes. The room was kept dim, lit only by the soft glow of computer monitors. The air conditioner hummed a low, steady note, the only sound that competed with the silence outside. Elias took a sip of his coffee. It was cold, but he drank it anyway. Caffeine was the fuel of astronomy. The date on his digital clock read October 18th, 2025. Elias loved this job. He loved the isolation. Many people thought astronomers spent their nights looking through an eyepiece at the stars like pirates looking through a spyglass. The reality was much different. Elias spent his nights looking at data streams, graphs and histograms on flat screens. He did not look at the stars directly. He looked at the digital ghosts of stars. He looked at light that had travelled for millions of years just to end its journey on a sensor in this building. Tonight was a routine observation night. The target was a specific sector of the sky that was supposed to be empty. The goal was to calibrate the background noise of the universe. It was boring work for most people, but for Elias it was peaceful. He watched the numbers scroll down his screen. He checked the wind speed sensors outside. Everything was perfect. The atmosphere was stable. The laser guide star, a beam of orange light shooting up from the observatory to measure the turbulence in the air, was steady. "Beautiful night," he whispered to himself. He stood up and stretched his back. His spine cracked. He walked to the small window that looked out onto the observatory floor. He could not see much, just the vague outline of the massive telescope structure in the gloom. It looked like a giant skeleton of steel. Elias thought about the light hitting the mirrors right now. That light left its source before human beings existed. It travelled through the vacuum of space, passing galaxies and nebulas, dodging dust clouds and gravity wells. It travelled at a speed of 300,000 kilometers per second, for eons, only to be caught in a bucket of glass on a volcano in the middle of the Pacific Ocean. It made him feel small. It made his problems, his rent, his loneliness feel very insignificant. That was the gift of the mountain. It gave you perspective. He sat back down at his station. The computer beeped softly. The exposure was finished. The raw data was processing. Usually a raw image from deep space looks like a mess of static. It looks like snow on an old television set. You have to clean it, process it, and remove the interference from the Earth's atmosphere. Elias began the standard routine. He typed in the commands to filter out the noise. His fingers moved automatically over the keyboard. He had done this 1,000 times. Filter the cosmic rays, filter the thermal noise, stack the images. The image began to clear on the main monitor. Elias leaned back, expecting to see a scattering of faint dots, distant galaxies that looked like smudges of light. But that is not what he saw. He blinked. He leaned forward, his nose almost touching the screen. "That is not right," he said aloud. His voice sounded too loud in the quiet room. In the center of the image, amidst the random scatter of distant stars, there was a shape. Nature creates many shapes. Nature creates spheres like planets. Nature creates spirals like galaxies. Nature creates chaotic clouds like nebulas. But nature does not create this. It was a perfect line. No, not just a line. As Elias zoomed in, the pixels resolved into something more complex. It was a structure. It looked like a grid perfectly dark against the faint background radiation of the universe. It was a lattice geometrically precise hanging in the void of deep space. Elias felt a cold drop of sweat slide down his back. He checked the coordinates. Right ascension and declination were correct. He checked the equipment status. The camera was operating at -100 degrees Celsius, perfectly cooled. There were no errors in the optical drive. Maybe it was a satellite number. A satellite would leave a streak of light because it moves so fast relative to the stars. This object was stationary. Or more accurately, it was moving at the exact same speed as the distant background stars, which meant it was incredibly far away. If it was that far away and he could see it this clearly, the size of the object had to be impossible. It would have to be larger than a sun. "It is a glitch," Elias muttered. "It has to be a software error." He reset the processing algorithm. He told the computer to reanalyze the raw data from the beginning. He waited. The seconds felt like hours. The hum of the air conditioner seemed to fade away until all he could hear was the beating of his own heart. It thumped against his ribs. Thump, thump, thump. The computer finished. The image popped up again. The structure was still there. It was elegant. It was terrifying. It was a shadow blocking out the light of the stars behind it. It looked like a gate, or perhaps a cage. Elias reached for his coffee cup, but his hand was shaking. He put the cup down before he spilled it. He looked around the empty control room. He suddenly felt very exposed. The silence of the mountain no longer felt peaceful. It felt like the silence of a person holding their breath, waiting for something to happen. He looked at the date on the screen again, October 18th, 2025. He typed a command to check the database. Had anyone else looked at this coordinate before the database spun and returned a result? No prior high-resolution imaging. This was the first time the Keck telescope had looked this deep into this specific patch of darkness. Elias felt a strange emotion rising in his chest. It was not fear exactly. It was a mixture of confusion and a wild, childlike curiosity. He felt like a boy who had turned over a rock in the garden and found a gold coin instead of a worm. He grabbed the phone on his desk. He needed to call the director. He needed to wake someone up. But then he stopped. His hand hovered over the receiver. If he called now, the noise would start. The questions, the panic, the media. The silence would be broken forever. He slowly pulled his hand back. He wanted to look at it alone for just one more minute. He wanted to be the only human being in the universe who knew the secret. He stared into the monitor, into the dark grid that defied all laws of nature. The object was silent, just like the mountain. It sat there in the void, waiting. Elias realized he was holding his breath. He exhaled slowly. The white noise of the room returned. The wind outside brushed against the metal dome of the observatory. The universe had just changed. The lonely empty dark was not empty anymore. Elias saved the file. He named it simply Anomaly 1. He looked out the window again. The sky was still black. The stars were still shining. But everything felt different. The architecture of silence had been broken not by a sound, but by a picture. He sat there in the dim red light, watching the impossible shape, and for the first time in his life, Dr. Elias Thorne was not sure if he wanted to know what was out there. But he knew one thing for certain: he could not look away. To understand the absolute impossibility of what we were seeing with 3i Atlas, we must first understand the fundamental laws of the neighborhood it had just entered. In the grand, silent theater of our solar system, comets are the most predictable of actors. They are ancient wanderers, often described by astronomers as dirty snowballs, composed of frozen gases, rock and dust left over from the dawn of planetary formation. They drift in the dark, deep freeze of the outer system, sleeping in a state of suspended animation. However, as a comet begins its long fall toward the inner solar system, it wakes up. This is a violent process. As it approaches the star at the center of our system, the temperature rises. The vacuum of space offers no insulation. The ice on the comet's surface does not melt into water. It skips the liquid phase entirely and explodes directly into gas, a process known as sublimation. This creates the coma, a glowing halo of gas and dust that surrounds the nucleus. This is where the invisible architecture of our solar system reveals itself. Space is not truly empty. It is filled with the breath of the sun. This breath manifests in two distinct forms, two invisible hands that shape everything they touch. The first hand is the solar wind. This is a relentless stream of charged particles, protons and electrons boiling off the surface of the sun and racing outward at nearly 1,000,000 miles per hour. It is a hurricane that never stops blowing. The second hand is radiation pressure. It is difficult for the human mind to grasp that light itself has physical weight that it can push against solid objects, but on the scale of cosmic dust, sunlight is a physical force. Photons, the tiny particles of light, slam into the dust grains released by the comet. They transfer their momentum, pushing the dust away. These two invisible hands, the solar wind and the pressure of light, conspire to create the comet's most iconic feature, the tail. This is the golden rule of cometary physics, a law as reliable as gravity itself. The tail does not trail behind the comet like the wake of a boat moving through water. Instead, the tail is always pushed away from the sun. It acts like a windsock at an airport. If a comet is travelling toward the sun, its tail flows behind it. But if a comet is travelling away from the sun, moving back out into the dark, its tail flies in front of it, leading the way. The sun is the master, and the comet's tail is the servant, always bowing away from the master's face. That is how it has always been. That is how physics works. Then came the high-resolution telemetry from 3i Atlas. At first, the data seemed like a glitch, a simple calibration error in the long-range sensors. The team in the control room assumed the orientation software was reading the data backward. They rebooted the systems, they checked the reference stars, they ran the diagnostics 3 times, but the image remained the same stubborn and terrifyingly clear. 3i Atlas was diving deep into the gravity well of the sun, moving at a velocity that would blister the paint off a conventional spacecraft. It was heating up just as a comet should. Its surface was sublimating, releasing a massive cloud of gas and particulate matter. But the material was not flowing away. The invisible hands of the sun were pushing with all their might. The solar wind was battering the object with a storm of charged particles. The radiation pressure was hammering it with the blinding force of a billion photons. By every known law of the universe, the cloud of gas and dust surrounding 3i Atlas should have been streaming out behind it, stretching into a long luminous tail pointing toward the outer darkness. Instead, the stream was flowing forward. It was a sight that made the blood run cold. The ejected material, the gas, the dust, the vapor was streaming directly toward the sun. It was fighting the wind. It was moving against the current. To the physicists watching the screens, it was as visually offensive as watching a waterfall pour upward, or watching a shattered glass reassemble itself on the floor. Imagine lighting a fire in a fireplace on a windy day. You expect the smoke to be drawn up the chimney by the draft. Now imagine the smoke turning around, fighting the updraft and pouring heavily back down into the room, defying the air pressure, defying the heat, moving with a singular unnatural purpose. That is what 3i Atlas was doing. The stream of matter was tight-focused and coherent. It didn't disperse like a natural cloud. It looked less like a tail and more like a tether. It appeared as though the object was extending a feeler, or perhaps a feeding tube reaching out toward the star it was orbiting. The implications rippled through the control room in a wave of hushed whispers. For this to happen, the particles being ejected had to be heavy, impossibly heavy, to punch through the solar wind, or they were being guided by a force we could not detect. We looked for magnetic fields. Comets usually have no magnetic field of their own. If 3i Atlas had a magnetic field strong enough to shield its ejector from the solar wind, it would need to be generating power on the scale of a small planet. The sensors swept the object again. The reading was flat. No magnetic bubble. No shield. We looked for gravitational anomalies. Was the object dense enough to pull its own exhaust back if it were a neutron star perhaps, but a neutron star would have torn the inner planets out of their orbits by now. 3i Atlas had the mass of a mountain, not a star. Gravity was not the answer. The paradox deepened the more we looked. The material flowing towards the sun was accelerating. It wasn't just drifting, it was being pulled or perhaps driven. The river was indeed flowing uphill, defying the gradient of the sun's influence. This was the moment the awe set in. It was a heavy, suffocating kind of awe. We weren't just looking at a strange rock anymore. We were looking at a violation of the natural order. When nature breaks its own rules, it is usually because we have misunderstood the rules. But the rules of solar wind and radiation pressure are simple. They are brute force. For something to overcome them without a visible engine, without a magnetic shield, and without massive gravity suggested that the object was interacting with physics in a way we had no language for. The material spiraled toward the sun, creating a dark, twisting bridge between the intruder and our star. It looked like an umbilical cord. The classic metaphor of the dirty snowball died in that moment. Snowballs do not reach out, snowballs do not ignore the wind. As the data continued to pour in, a new unsettling realization took hold. The smoke going down the chimney wasn't just escaping gas. The spectral analysis suggested it was organized. The flow had structure. It was rhythmic pulsing with a heartbeat that matched no known natural frequency. We sat in the blue light of the monitors watching the impossible unfold. The river flowed uphill, the wind blew, but the fag pointed the wrong way. And in that silence, the gap between what we knew of the universe and what was happening on the screen became a canyon. We were no longer studying astronomy. We were witnessing a miracle, or perhaps an invasion. To the uninitiated eye, the delivery of the data would look remarkably anticlimactic. It did not arrive as a glossy photograph sliding out of a printer, nor did it appear as a sudden high-definition image flashing across a monitor in a mission control room. Instead, it arrived in crates, It came as half a ton of hard drives flown on commercial airplanes from mountain tops and icy plateaus converging on supercomputers in Germany and the United States. When the scientists finally plugged these drives in, they were not looking at a black hole. They were looking at static. This is where the romance of discovery meets the grueling reality of the scientific method. The raw data collected from the Event Horizon Telescope was a messy, chaotic storm of information. It was a digital blizzard. For every piece of genuine signal from the center of galaxy M87, there were mountains of noise. The telescopes had not just recorded the light from the black hole, they had recorded the heat of their own electronic circuits, the static of the local power grids, and most frustratingly, the Earth's atmosphere. Water vapor in the sky is the great enemy of radio astronomy. To these sensitive instruments, a passing cloud or a humid night acts like a frosted glass shower door, distorting and scattering the sharp details of the universe. Before any image could be found, this fog had to be mathematically wiped away. This process requires a level of meticulousness that borders on obsession. The teams did not just clean the data, they scrutinized every single fluctuation. They had to filter out false signals caused by cosmic rays high-energy particles from deep space that slam into the detectors and create bright, misleading sparks. These sparks are the imposters of the astronomy world. If a scientist is not careful, a random cosmic ray hitting a sensor in Hawaii can look suspiciously like a star flare billions of miles away. The researchers spent months writing algorithms to identify these imposters. They had to teach their computers to tell the difference between the majestic radio waves of a black hole and the mundane electronic hum of a camera that was slightly too warm. It was a task of subtraction. They were chipping away the marble to reveal the statue underneath, terrified that if they chipped too hard they might accidentally remove the truth. Then came the moment of cognitive dissonance. As the noise was stripped away, a shape began to emerge from the darkness of the data. It was a ring, a bright glowing donut of fire surrounding a central patch of absolute nothingness. For a member of the public, this would be a moment of triumph, but for a trained physicist, this moment induces a deep stomach-churning anxiety. This is the discomfort of cognitive dissonance, the mental conflict that occurs when what you see challenges what you believe, or when the magnitude of a discovery feels too perfect to be real. The structure appeared too clean. It fit the theoretical predictions of Einstein's general relativity so perfectly that it felt suspicious. In the messy world of experimental physics, things rarely line up exactly with the math on the first try. Usually there are smudges, artifacts, or distortions. To see such a clear shadow felt like a trap. The immediate reaction was not celebration, but accusation. The scientists did not say we found it. They asked, what did we break? They assumed the ring was a mistake. They assumed it was an artifact, a digital ghost created by the software itself. Perhaps the code used to stitch the telescope data together had a bias toward making circles. If you tell a computer to look for a face in the clouds, it will eventually find one. Had they accidentally told their algorithms to find a black hole? This sparked a phase of aggressive self-skepticism. This is the art of the discipline you must try to destroy your own discovery. The teams launched a campaign to prove the image was fake. They tweaked their settings to unimaginable extremes. They deliberately fed the computers bad information to see if the ring would persist. They ran the data through entirely different processing pipelines written by different people in different coding languages. If the ring was a technical glitch, it would vanish when the processing method changed. A glitch is fragile, the truth is robust. The most profound step in this process was the use of blind imaging. To ensure that human desire wasn't influencing the result, the collaboration split into 4 separate teams. These teams were isolated from one another. They could not share images, they could not text each other about their progress, and they could not discuss their findings. They were given the same raw data but were forced to work in solitary confinement. For weeks, 4 different groups of humans, separated by oceans and time zones, stared at the same petabytes of static, applying their own unique logic to solve the puzzle. The fear was palpable. If Team A produced a ring and Team B produced a blob and Team C produced 2 dots, the experiment would be considered a failure. It would mean the data was too messy to trust. The credibility of the entire project hung on this blind test. On the day of the reveal, the teams gathered in a room and via video link to show their work. One by one they revealed their images. Team 1, a blurry golden ring. Team 2, a blurry golden ring. Team 3, a blurry golden ring. Team 4, a blurry golden ring. The silence in the room was not just relief, it was a heavy, profound reverence. The dissonance vanished. The skepticism had done its job. It had scrubbed away every possibility of error, every chance of a digital illusion, and every potential for human bias. What remained on the screens was not a glitch. It was not a smudge on a lens. It was not a trick of the code. The structure was real. It was a physical object 55 million light-years away, finely stripped of the noise of the universe and the doubt of the human mind. It was a monster that had survived the most rigorous interrogation humanity could devise. Science at its core is a deeply skeptical practice. In the world of astronomy, seeing something once is never enough. A single observation, no matter how exciting, can always be a mistake. It could be a glitch in the computer software, a smudge on the lens, a reflection from a satellite, or simply a sensor error. To turn a maybe into a truth, you need confirmation. You need a convergence of eyes. When Pan-STARRS first spotted the intruder, it was just a single point of data. But as the alarm bells rang out across the global astronomical community, the lonely vigil of one telescope transformed into a planetary effort. The story of Oumuamua ceased to be about a single observatory in Hawaii. It became the story of humanity turning its collective head to look at a fleeing visitor. The view from above. Hubble enters the fray. By July, the object was moving deep into the darkness, racing away from the sun. It was becoming incredibly faint, dimmer than the faintest stars visible to the naked eye by a factor of millions. Ground-based telescopes were struggling to keep track of it against the background noise of the universe. We needed a clearer view. We needed the king. In late June and early July, the Hubble Space Telescope was commanded to swing its gaze toward the retreat. Orbiting high above the Earth's distorting atmosphere, Hubble offers a clarity that no mountaintop observatory can match. Its participation was crucial. If this object was a comet, as many still assumed, Hubble would see the coma, a cloud of gas and dust surrounding the center. The data came back and it was shocking in its emptiness. Hubble stared at the coordinates, taking long exposure images. It saw the object, but it saw nothing else. There was no cloud, there was no tail, there was no fuzzy halo of evaporating ice. Oumuamua was a sharp, singular point of light. This was the definitive moment that killed the normal comet theory for good. Through Hubble's unblinking eye, we learned that Oumuamua was tight, compact, and solid. It wasn't shedding material. This made the mystery of its movement even deeper. If it wasn't releasing gas to push itself like a rocket, why was it moving so strangely? Hubble had clarified the picture, but in doing so, it had deepened the puzzle. The Southern Watch, Gemini South. As the summer pressed on into August and September, Oumuamua moved into the southern skies. The observatories in the northern hemisphere, like those in Hawaii, could no longer see it well. The baton had to be passed. The pursuit moved to the Chilean Andes, home of the Gemini South Telescope. This is a massive machine with a mirror over 8 meters wide, designed to capture the faintest whispers of light from the edge of the universe. Now it was being used to chase a tiny rock right in our own solar neighborhood. By August, Oumuamua was a ghost. It was millions of miles away, fading rapidly into the black. The astronomers at Gemini South were fighting against time. Every night the object became harder to see. They were collecting the final scraps of data, the last breadcrumbs the visitor would ever leave us. These observations in August and September were critical for a concept known as pattern recognition. When you have one photo, you have a snapshot. When you have photos from June, July, August, and September taken by different machines, processed by different computers, and analysed by different teams, you have a pattern. The data from Gemini South matched the data from Hubble, which matched the data from Pan-STARRS. They all told the same story: the object was tumbling. It wasn't spinning smoothly like a planet. It was flipping end over end. Its brightness would dim, then flare up, then dim again, repeating this cycle every 7 to 8 hours. This light curve confirmed that the object was incredibly long and thin, perhaps cigar-shaped, or flat like a pancake. Only a strange shape could cause such dramatic changes in reflected light as it tumbled, from observation to global truth. This period represented a shift from discovery to verification. This is the difference between a rumour and a fact. If only one person sees a ghost, it is a story. If 1,000 people in a stadium point to the same spot and scream, it is an event. The astronomical community operates like a global brain. During these months, the nerves of this brain fibre optic cables connecting Chile to Europe, Hawaii to New York were firing rapidly. The consensus was building. This was not a mistake. This was not a simulation. We saw the power of independent verification. The telescopes in the Canary Islands saw the same colour spectrum, a reddish hue, as the telescopes in Chile. The radar dishes tracking its speed agreed with the optical telescopes tracking its light. This agreement allows us to rule out human error. It strips away the ego of individual scientists and leaves only the raw data. and the data was screaming that this object was unlike anything we had seen before. The non-gravitational acceleration, the fact that it was speeding up slightly pushing away from the sun without a visible tail, was confirmed by this convergence. If it had been a mistake in the Pan-STARRS data, Hubble would have corrected it. If Hubble had a glitch, Gemini South would have revealed it. But they didn't. They all pointed to the same impossible truth: the object was moving under a power we could not see. The emotional resonance of the effort. There is something profoundly moving about this phase of the story. For a brief window of time, humanity forgot its borders. Usually the world is divided. We worry about politics, economies, and local disputes. But for those few months, the eyes of the species were united. An astronomer in the dry deserts of Chile was looking at the exact same photon stream as an astronomer on the dormant volcanoes of Hawaii. They were asking the same questions. They were sharing the same anxiety that the object was leaving before we could fully understand it. It brings a sense of scale to our existence. We realize that we are all standing on the same small rock looking out a window at a vast, busy neighborhood at Oumuamua was leaving. By the time Gemini South took its final readings in late September, the object was racing toward the orbit of Saturn, vanishing into the eternal dark. We would never see it again. We could not send a rocket to catch it. It was too fast. We could not take another picture. It was too faint. All we were left with was the data. But because of this convergence of eyes, because of the Hubble in July and Gemini in August, that data was robust. It was solid. It was a set of facts that would haunt scientists for years to come. We had the what. We knew it was red, tumbling long and accelerating. But as the telescopes finally turned away, defeated by the distance, we were left with the terrifying and wonderful realization that we still did not know the why. The eyes of the world had converged, they had seen the truth, and yet the mystery remained unsolved. On October 3rd, 2025, the space around Mars was silent. It is always silent, of course, but on this specific day, the silence felt different. It was the silence of waiting. While the people of Earth were looking up at the sky with panic and confusion, the red planet was simply continuing its lonely orbit around the sun, millions of kilometers away from the chaos. However, Mars was not entirely alone. Circling the planet were the mechanical ambassadors of humanity. They were the robotic explorers that we had sent there years ago. Among them were two European spacecraft, the ExoMars Trace Gas Orbiter, often called TGO, and the aging veteran known as Mars Express. Usually these machines spend their entire lives looking down. They are obsessed with the ground below them. They scan the red dust for signs of water. They sniff the thin atmosphere for traces of methane gas. They map the valleys and the ancient volcanoes. They were built to look at the planet, not to look away from it. But on this day, the commands coming from the control centers in Europe were different. The instructions were urgent and unusual. Stop looking at Mars. Look out into the dark. The target was the Traveller. This was the mysterious object that had caused so much fear back on Earth. It was passing through the inner solar system, and its path took it relatively close to Mars before it would reach Earth. For a human photographer, turning a camera to take a picture of a passing car is easy. For a spacecraft orbiting a planet, it is an incredibly difficult physical challenge. These machines are heavy and move at high speeds, thousands of meters per second. To turn them around is like trying to steer a massive ship in a completely new direction while it is moving at full speed. Mars Express faced the hardest challenge. It was an old machine launched all the way back in the year 2003. By 2025, it was a tired survivor. Its batteries were not as strong as they used to be, and its gyroscopes, the spinning wheels that help it keep its balance, were worn out. The engineers back on Earth were terrified if they forced the old ship to turn too quickly to track the fast-moving Traveller. They risked losing control of it forever. It might spin out into the void, its antenna pointing away from Earth, never to be heard from again. Yet they took the risk. Inside the computer brain of Mars Express, a line of code executed. The spacecraft began a slow, painful rotation. It had to ignore the red planet below. It turned its scientific eyes toward the deep, black ocean of space. It was searching for a needle in a haystack. Meanwhile, the ExoMars TGO was also moving. It was newer and stronger, but it had its own problems. Its camera, called KCS, was designed to take detailed color 3D images of static rocks on the ground. It was not designed to take pictures of a bright, fast object zooming through space. The exposure settings had to be changed completely. If the shutter stayed open too long, the Traveller would just be a blurry line. If it was too short, the camera might see nothing at all. The distance between Mars and the Traveller was still very large, millions of kilometers. To the sensors on these ships, the object was not a giant monster. It was just a faint moving spark. For a few tense hours, the machines worked in the cold dark. There was no sound of motors, only the silent vibration of reaction wheels spinning inside the metal frames. They were lonely witnesses watching an event that no human eye could see from that angle. They were the only eyes we had in that part of the solar system. When the data finally began to stream back to Earth, travelling at the speed of light across the vast distance, the scientists waited with bated breath. The transmission was slow, the signals were weak. When the images finally appeared on the screens in the control room, they were not beautiful. They were not like the stunning high-definition pictures we are used to seeing in movies. There were no swirling clouds of colour or dramatic lighting. The photos were mostly black. In the centre of the frame there was just a smudge. In one image from Mars Express, it was a jagged, pixelated blob of white light against a grainy background. In the image from TGO, it was a faint streak slightly out of focus. To the average person, these photos might have looked like mistakes. They looked like a picture taken by a broken camera in a dark room. But to the scientists and to the historians of the future, these blurry images were precious. They were absolute gold. The reason they were so valuable was because of parallax. This is a simple concept. If you hold your finger in front of your face and close your left eye, then switch and close your right eye, your finger seems to jump to the side. This happens because your eyes are looking from two different positions. This difference allows your brain to calculate distance and depth. For weeks, Earth had been looking at the traveller with only one eye, the telescopes on and around Earth. We could see where it was, but it was hard to be 100% sure of exactly where it was located in 3D space. But now we had a second eye, Mars. By comparing the view from Earth with the blurry, grainy photos from the spacecraft at Mars, mathematicians could create a perfect triangle. They could pinpoint the exact location of the traveller to within a few meters. They could confirm its speed with absolute certainty. The blurry photos proved that the object was real. They proved it was exactly where the frightening calculations said it was. There was no more hope that it was just a measurement error. The witness at Mars had spoken. But beyond the science, there was a deep emotional weight to this moment. There was a strange beauty in it. Think of these machines. We built them with our own hands. We used screwdrivers and wires and metal foil. We launched them on rockets of fire. And then we left them there millions of kilometers from home. They orbit a dead, frozen world year after year in total isolation. On that day, October 3rd, 25, they did exactly what we asked them to do. Like loyal dogs guarding a house, they turned their heads to watch the danger approaching their masters. They strained their old mechanical joints. They used their fading power. They captured the truth and sent it home across the silence. The images were ugly, but the act was beautiful. It showed that even when humanity is terrified and facing a threat, our curiosity and our creations are still out there functioning, watching and helping us understand the universe. After the traveller passed, the commands were sent again, returned to normal operations. Slowly, Mars Express and TGO turned back. They pointed their sensors down once more toward the red dust and the ice caps of Mars. They went back to their lonely work, leaving the traveller to continue its journey toward Earth. The witness at Mars had done its job. The silence returned, but now, thanks to those faint, grainy photos, the people on Earth knew exactly what was coming for them. We have spent a long time looking at how much light comes from KC 84628552. We watched the dips, we watched the dimming, we tracked the erratic heartbeat of a star that refused to follow the rules of astronomy. But tracking the brightness only tells us the size of the shadow. To truly understand what is casting that shadow, we have to stop looking at the quantity of the light and start looking at its quality. We have to look at the fingerprint, reading the rainbow. To understand the most baffling clue in this cosmic mystery, we must first understand a beautiful tool called spectroscopy. Imagine you have a prism. When sunlight hits that prism, it shatters into a rainbow of colours from violet to red. This is a spectrum. But if you look very closely at that rainbow from a star, it is not a perfect continuous band of colour. There are tiny dark gaps. It looks like someone has erased thin, vertical lines from the rainbow. These dark lines are the barcodes of the universe. Every chemical element in existence, hydrogen, helium, carbon, oxygen, interacts with light in a unique way. When light passes through a cloud of gas or dust, the chemicals in that cloud steal specific colours from the rainbow. Oxygen steals a specific shade of red, sodium steals a specific shade of yellow. By looking at which colours are missing from the starlight, astronomers can tell you exactly what the object blocking the light is made of. We do not need to travel 1400 light-years to scoop up a sample of the dust surrounding Tabby's star. We just need to read the missing lines in the rainbow. It is the ultimate act of touching the untouchable, the metallic fog. When astronomers finally managed to capture the spectrum of the light passing through the mysterious debris around Tabby's star, they expected to see the standard recipe of the universe. In a typical cloud of space dust, the kind born from smashed asteroids or dissolving comets, we expect to see a lot of silicates. Silicates are basically rock dust, the same stuff that makes up sand and mountains on Earth. We also expect to see water ice and carbon. This is the standard dirty snowball mix of the galaxy. But when the data came back from KIC 8462852, the barcode was wrong. The chemical signature did not look like a smashed rock, it looked like a furnace. The light revealed a massive, overwhelming presence of heavy metals. Specifically, the data shouted two names, iron and nickel. Finding metals in space is not impossible. Asteroids have metal cores, but usually that metal is buried inside rock. To see this much distinct metallic signal, the dust had to be incredibly fine, like a metallic smoke, and it had to be dominating the view. The impossible recipe. The mystery deepened when scientists looked at the ratio of these metals. In nature, elements usually hang out together in predictable families. If you pulverize a rocky asteroid in our solar system, you'll get a mixture of iron and nickel, but the ratio is usually heavily skewed toward iron mixed with magnesium and other distinct elements. It is a natural alloy. However, the signature coming from the debris around Tabby's star showed a ratio of nickel to iron that was startling. It was too balanced. It did not look like the messy, chaotic core of a dead planet. To an engineer's eye, the specific mixture of iron and nickel stripped of other common debris looked suspiciously familiar. On Earth, when we purify iron and mix it with nickel in specific amounts, we are not making rocks. We are making stainless steel. This is where the alien megastructure theory suddenly got a second wind. If you were a civilization building a massive solar array or a giant ring around your star, you would not build it out of sandstone and ice. You would build it out of high-strength alloys. You would build it out of steel. If such a structure were damaged, perhaps hit by an asteroid or degrading over thousands of years, the debris field wouldn't look like a comet's tail. It would look like a cloud of scrap metal. The spectrum we saw matched the profile of industrial wreckage closer than it matched a natural dust cloud. The timeline anomaly. Just when astronomers thought it couldn't get stranger, they looked at the timing of the signal. As the cloud of debris passed in front of the star, the chemical signal changed. This allows us to map the structure of the cloud. If it were a simple cloud of mixed dust, we should see the iron and nickel signals rising and falling together. After all, if you blow up a car, the steel from the door and the steel from the hood fly through the air at the same time. But that is not what happened. The data suggested that the nickel appeared in the spectrum before the iron. There was a separation. As the object moved across the star, the telescope tasted nickel first and iron second. In the vacuum of space, facing the pressure of starlight, gas and dust are pushed by the star's radiation. Lighter elements are pushed harder than heavy ones. This is a natural sorting machine. However, iron and nickel have very similar atomic weights. They are neighbours on the periodic table. The star's light should push them with almost identical force. They should not be separated by this much distance within the same cloud. For nickel to arrive before iron implies a level of sorting and separation that nature rarely achieves on its own in such a short span. It implies that the source of the nickel and the source of the iron might be different components of the same object trailing behind one another in a rigid formation, rather than a chaotic mixed-up cloud of dust. The ghost in the machine. This discovery sent a shiver through the scientific community. We were no longer just looking at a star winking at us. We were analysing the smoke from a fire and discovering that the fuel wasn't wood, it was metal. It forces us to confront an uncomfortable question. What natural process creates a cloud of microscopic dust that resembles industrial steel? What natural event separates these twin metals into neat, organised columns? We have tried to model it. Perhaps a planetary collision where the mantle was stripped away, leaving only the core. Perhaps a very specific type of asteroid that evaporated near the star. These are possible, but they require a just-so story where every condition is perfect. The alternative is that we are looking at the blood of a dead machine. We might be detecting the vaporized remains of a structure built by hands or appendages unknown to us. Spectroscopy allows us to touch the star. We reached out across the dark ocean of space expecting to feel the rough grit of asteroid rock or the cold slush of comets. Instead, our fingertips grazed something smooth, metallic and refined. We touched the dust and it felt like a ruin. We have spent a great deal of time looking at the biological possibilities, but now we must turn our gaze toward the chemical. When we strip away the theories of algae or blood, we are left with a hypothesis that is both elegant and disturbing: the presence of carbonyl metals, specifically a substance known as iron pentacarbonyl. To the uninitiated, this sounds like just another complex chemical name, but in the context of the red rain and the strange phenomena in the sky, it represents a specific fingerprint. It is the fingerprint of industry, not of nature. To understand why this hypothesis is so controversial, we first have to understand what this substance actually is. Imagine taking a solid piece of iron, hard, heavy and metallic, and convincing it to become a liquid at room temperature, or a gas when slightly heated. This is the magic of iron pentacarbonyl. It is a compound where a single atom of iron is trapped inside a cage made of 5 carbon monoxide molecules. When this liquid is exposed to air and sunlight, it breaks down rapidly. The invisible cage shatters and the iron inside rusts instantly, creating a cloud of fine red iron oxide dust. If this happens in a rain cloud, that red dust mixes with water and you get red rain. On paper, this fits the physical evidence perfectly. It explains the colour, the sudden appearance and the lack of DNA. But here is where we hit a wall built by the laws of thermodynamics. In our human world, creating iron pentacarbonyl is not a mystery. We do it every day in factories. It is known as the Mond process. However, this process is violent and demanding. To force carbon monoxide to bond with iron, we typically need high pressure and carefully controlled temperatures. It is a brute force method. We crush the ore we pump in dangerous gases, and we cook the mixture in massive steel vessels. It is the chemistry of the furnace and the forge. It is a hot, heavy, energetic process designed to overcome the natural reluctance of these elements to bond. Now try to transport that process into the upper atmosphere. The hypothesis suggests that this compound formed naturally in the sky. This is what we might call the alchemy of cold. The atmosphere is not a controlled steel vessel, it is a chaotic open system. For this compound to form naturally, a series of nearly impossible conditions would have to align perfectly, like a house of cards built inside a tornado. First, you would need a source of extremely pure iron. Ordinary dust from meteors or the ground is usually mixed with oxygen or silica. To make carbonyls, the iron needs to be reduced, meaning it has been stripped of oxygen and is chemically hungry. Finding vast clouds of pure unoxidized iron floating in the atmosphere is already incredibly rare. Second, you need carbon monoxide, not just the trace amounts found in pollution, but a concentrated cloud of it. In the open sky, gases disperse. They drift apart. To get the iron and the gas to meet in high enough concentrations to react would require a density that simply does not exist in nature. It would be like trying to bake a cake by throwing flour and eggs into the wind and hoping they mix together before they hit the ground. Third, and perhaps most difficult, is the trap of energy. The reaction that creates this substance releases heat. In a factory, we manage this heat. In the sky, the reaction would likely reverse itself immediately. Furthermore, ultraviolet light, sunlight, is the mortal enemy of iron pentacarbonyl. Sunlight breaks the bonds as fast as they form. Therefore, this natural alchemy would have to happen in total darkness, perhaps inside a dense opaque cloud, or at night, shielding itself from the very star that lights our solar system. When you stack these conditions, the probability collapses. You need pure metal, high gas concentration, specific pressure and total darkness all happening simultaneously in the chaotic winds of the upper atmosphere. Nature is a master creator, yes. It creates diamonds from carbon and clouds from water, but nature usually follows the path of least resistance. The creation of complex carbonyl metals is a path of immense resistance. It requires an orchestration of variables so precise that it stops looking like a weather pattern and starts looking like a laboratory experiment. This brings us to the emotional core of this mystery. If the universe in its cold natural state cannot reasonably create this substance, then where did it come from? We are forced to look at the boundary between the natural and the artificial. When we see a hexagonal honeycomb, we know bees made it. When we see a perfectly round crater, we know a meteor or a volcano caused it. These are natural shapes. But liquid metal that turns into red rain is not a natural shape. It is a technological shape. If this substance was present in the clouds over Petrozavodsk or Kerala, it implies that the phenomenon was leaking. It suggests that the glowing spheres seen by witnesses were not just lights or optical illusions, but physical craft operating with engines or fuel systems that utilize this chemistry. In the 1970s and 80s, scientists investigated carbonyls as additives for radar-absorbing paint or high-efficiency fuels. The chemistry is distinctly utilitarian. The alchemy of cold is therefore a mirror. When we stare into it hoping to see a freak weather event, we instead see the reflection of a machine. It forces us to ask a question that makes us feel very small. Are we looking at the exhaust fumes of a visitor? The red rain becomes less of a biological mystery and more of a pollution event. But it is not our pollution. It is the waste product of a technology that we can barely comprehend operating in our skies with impunity. It suggests that the natural world we think we understand, the rain, the wind, the clouds, might occasionally be contaminated by the artificial byproduct of something else. The boundary blurs. If a tree falls in the forest, it is nature. If a chemically refined metal falls from the sky, it is manufacture. And if there is no human factory above the clouds to manufacture it, then the sky itself has become a workshop for an unknown mechanic. We are left standing in the rain, realizing that the water touching our skin might be the runoff from an engine that is not supposed to exist. The silence of deep space is deceiving. While it seems empty, it is full of information if you have the right eyes to see it. For 3i Atlas, our eyes were the golden mirrors of the James Webb Space Telescope. Floating 1 million miles away from Earth in the cold shadow of our planet, this telescope turned its gaze toward the intruder. What it found was not just a list of chemicals, but a revelation that turned our understanding of how solar systems are built completely upside down. When astronomers look at comets from our own solar system, they expect a specific recipe. We call them dirty snowballs for a reason. They are made mostly of frozen water mixed with dust and small amounts of other gases. Water is the standard solvent of our corner of the universe. It is the liquid of life, the ice of our poles, and the vapor in our clouds. When a comet from our family gets close to the sun, it heats up and the water ice turns into steam. This is what creates the beautiful glowing tails we see in the night sky. We assumed 3i Atlas would follow these same rules. We were wrong. As the data from the James Webb Telescope began to stream back to Earth, the chemical fingerprints of the object appeared on the screens of mission control. It was a spectrograph that shows how light interacts with the gas surrounding the object. Every molecule leaves a unique mark, like a signature. The scientists were looking for the massive, tall spike that represents water. It wasn't there. Instead, the graph showed something that looked like a mistake. Where the signal for water should have been huge, it was tiny, barely a whisper. But right next to it, another signal was screaming. It was a massive, dominant spike for carbon dioxide. To understand how strange this is, you have to imagine walking into a bakery expecting the smell of bread, but instead, the air is thick with the smell of gasoline. It is a chemical contradiction. In our solar system, for every 1 molecule of carbon dioxide in a comet, there are usually dozens or hundreds of molecules of water. On 3i Atlas, the ratio was flipped. It was inverted. There was almost no water at all. The object was not a snowball, it was a dry iceberg. This discovery solved the riddle that had been bothering astronomers for months, the mystery of the distance. When 3i Atlas first began to wake up and release gas, it was still very far away from the Sun. It was drifting through the dark, cold gap between the orbits of the outer planets. At that distance, the heat from the Sun is incredibly weak. It is far too cold for water ice to melt or turn into gas. A normal comet made of water would be frozen solid, hard as a rock, and completely invisible. It should have been sleeping, yet 3i Atlas was active. It was breathing out gas and creating a coma. The carbon dioxide explanation made all the pieces fit together perfectly. You might know carbon dioxide in its solid form as dry ice. We use it on Earth to keep shipping containers cold or to create spooky fog effects at concerts. The unique thing about dry ice is that it is extremely volatile. It does not need a hot summer day to turn into gas. It can turn from solid ice to gas at temperatures far below freezing. While water ice remains stubborn and hard in the deep freeze of space, carbon dioxide ice is fragile. Even the tiny, weak warmth of the distant sun was enough to make the surface of 3i Atlas hiss and crack. It was shedding its skin long before a normal comet would. This paints a haunting picture of the object's surface. If you were standing on 3i Atlas, you would not see the white glistening frost we know on Earth. You would see a strange translucent landscape. As the sunlight hits the surface, it doesn't create puddles of liquid. There is no melting. The ground simply vanishes. The ice turns directly into invisible gas, violently expanding and blasting dust out into the void. It is a landscape of sublimation where the ground is constantly disappearing beneath your feet, turning into a ghost. But the implications go deeper than just the mechanics of how it melts. The composition of this object tells us a story about where it was born, a story that takes place in a world completely unlike our own. Star systems are born from giant clouds of dust and gas. Our cloud, the nebula that created the Sun and the Earth, was rich in oxygen. Oxygen loves to bond with hydrogen to create water. That is why we live on a water world in a water system. Because of this, we tend to think that water is the standard building block of the universe. Atlas proves that this is not always true. For an object to have so much carbon dioxide and so little water, It must have formed in a place where the chemistry was fundamentally different. It suggests a carbon world. Perhaps 3i Atlas was born around a star that had much more carbon than oxygen in its atmosphere. In such a system, the planets and moons would not be made of silicate rocks and water oceans like ours. They might be made of graphite carbides and oceans of tar or methane. The snow falling on those worlds would be dry ice snow, or perhaps it formed in the dark, freezing outer edges of a nebula that was so cold that even carbon monoxide froze solid, trapping the oxygen before it could ever find hydrogen to make water. It implies a birth environment that is darker, colder, and chemically backward compared to the warm, watery nursery of our Earth. This realization creates a profound sense of alienation. When we looked at 3i Atlas through our telescopes, we were projecting our own history onto it. We wanted it to be like us. We wanted it to be a traveller bringing water, perhaps the same kind of water that seeded the early Earth. Instead, 3i Atlas is a messenger from a different reality. It is a reminder that the recipe for our solar system is just one page in a very large cookbook. Out there in the deep galaxy, there are worlds where the snow burns, where the ice is dry, and where water is as rare as gold. As 3i Atlas moves closer to us, it is shedding this alien atmosphere. It is bleeding its carbon blood into our solar wind. It is a traveller from a dry, cold, carbon-heavy empire passing through our water-rich kingdom. It does not belong here. Its chemistry is fighting against the heat of our sun, breaking down in ways that are violent and unpredictable. The backward ice is not just a scientific curiosity. It is a physical boundary line. It defines the difference between us and them. It shows us that what we consider normal water oxygen silicate rocks might actually be the exception. 3i Atlas is a piece of debris from a star system that followed a different path. A path where life, if it exists, would look nothing like the biology we know. It is a silent, smoking monument to the diversity of the cosmos drifting through our backyard, totally indifferent to our rules of nature. In the vast, silent theatre of deep space, nothing truly stands still. Even the stones that float in the void have a rhythm, a dance, or a heartbeat. As the stranger moved past our sun, escaping the gravity that tried to hold it, we began to listen to its pulse. It was not a sound we could hear with our ears, but a pattern of light we could see with our eyes and our telescopes. This pulse was steady, hypnotic, and undeniably strange. We measured the heartbeat of the visitor at exactly 16.16 hours. This was the time it took to complete a full rotation. For astronomers, a rotation period is like a fingerprint. It tells us about the history of the object and the forces acting upon it. But the stranger did not spin simply like a toy top or a planet. It tumbled. Imagine throwing a long, thin stick into the air. It does not just spin around its middle. It flips end over end, twisting and turning in a complex, chaotic loops. This is how the stranger moved through the dark. It was a tumble that seemed violent yet graceful, a motion that had likely continued for millions of years in the emptiness between the stars. This tumbling motion gave us our biggest clue about its shape. We could not resolve a clear picture of the object because it was too small and too far away. Instead, we watched its light. This is known as a light curve. As the object tumbled, the amount of sunlight reflecting off its surface changed. When the long side of the object faced the sun, it acted like a wide mirror reflecting a lot of light. It appeared bright to our telescopes. Then as it turned and pointed its narrow end toward us, the surface area became tiny, and the light faded away almost completely. The difference between the brightest moment and the darkest moment was extreme. The brightness dropped by a factor of 10. In the natural world of asteroids and comets, this is almost unheard of. Most space rocks are shaped like potatoes, lumpy and roundish. When a potato spins, the light changes a little bit, perhaps by 10 or 20%, but for the light to drop 10 times over the object had to be incredibly long and thin. The data painted a picture of something stretched out, perhaps cigar-shaped or flat, like a pancake spinning wildly. Every 16.16 hours, the lighthouse beam of the stranger would flash, then fade into the darkness, then flash again. There was a hypnotic quality to this data. It felt less like watching a rock drift by, and more like watching a signal repeating in the night. However, as we watched this rhythmic tumbling end, we noticed something that broke the rules. In a normal comet, the rotation is often affected by the sun. As sunlight hits the frozen surface, ice turns into gas. This gas shoots out in jets, creating the famous tail or coma of a comet. These jets act like small rocket thrusters. If a jet shoots out from the side, it makes the comet spin faster. If it shoots from the front, it slows the rotation down. We looked for these jets on the stranger. We looked for the coma, the fuzzy cloud of gas and dust that surrounds every other comet we have ever seen. We saw nothing. The space around the object was perfectly clean. There was no dust, no visible gas, and no tail streaming behind it. To the visible eye, it was a dead stone. And yet the object was accelerating. It was being pushed by something other than gravity. This created a deep contradiction in our minds. If it was a comet, it should have a visible tail. If it had no tail, it should be an asteroid. But if it was an asteroid, it should not be accelerating. The stranger refused to fit into either box. This brought us to the asymmetry of the situation. If there were invisible gas jets pushing the object, they were not behaving normally. Usually as a comet rotates, the jets spray out in a pattern that matches the fin. It is a messy natural process. But the stranger's motion felt different. The way it tumbled combined with the way it accelerated suggested that the push was not coming from random surface explosions. It felt concentrated, it felt specific. This is where the feeling shifted. When you look at a rock, you expect chaos. You expect a rough surface, a random spin, and a predictable path defined only by gravity. But as we analysed the 16.16-hour cycle, a sense of unease began to settle in the scientific community. The object felt less like a space potato and more like a machine. Consider the structural integrity required to spin that way. If you take a pile of loose gravel and spin it rapidly, it will fly apart. Many asteroids are just rubble piles, loose rocks held together by weak gravity. But the stranger was spinning and tumbling with high energy. If it were a loose pile of rocks, the centrifugal force would have torn it apart long ago. To hold its shape while tumbling that fast and while being so long and thin, the object had to be solid. It had to be made of something strong, rock metal, or something else. The light curve was too perfect in its extremes. The rotation was too complex. The acceleration was too smooth for an object with no visible engine. The more we stared at the data points on the screen, the more the image of a natural rock faded. In its place, the imagination began to draw a different picture. We began to imagine a derelict hull. We imagined a darkened cylinder tumbling through the void, its systems powered down, dead and silent, yet retaining the momentum of a journey that began before humanity existed. The rhythm of 16.16 hours became a sort of countdown. It was the pulse of a sleeping giant. This was the uncanny valley of astronomy. The object was close enough to looking natural that we wanted to believe it was just a rock, but it was just different enough, too long, too shiny, too fast, that it triggered a primal instinct. It triggered the feeling that we were looking at something built. The asymmetry of the invisible coma added to this mechanical feeling. If the gas was venting, it was venting from specific points, almost as if it were exhaust. It did not spray everywhere like a natural comet melting in the sun. It pushed the object on a specific trajectory. We were left with a haunting duality. On the paper in the peer-reviewed journals, we wrote about outgassing and unusual geometry. We used safe words. We stuck to the physics of ice and stone. But in the quiet of the observatories, watching that line on the monitor dip and rise, dip and rise, the thought lingered. The regularity of the tumble was mesmerizing. It was a clock ticking in the dark. The stranger was not just passing through, it was performing. It was showing us a dance that defied our simple categories of comet or asteroid. It was a heavy, metallic, rhythmic dancer. As the stranger moved away, the pulse became harder to read. The signal grew weaker. The 16.16-hour beat began to fade into the background static of the universe. But the impression it left was permanent. We had looked into the face of the unknown, expecting a simple stone, and the unknown had blinked back at us with the precision of a machine. The most disturbing feature of this object, the detail that keeps astronomers awake long after their shifts have ended, is the tail. To the untrained eye, a tail is simply a streak of light behind a comet. But to those who understand the mechanics of the heavens, this particular tail is a violation of the rules we thought were absolute. It is what we call an anti-solar tail, but not the kind we can explain away with geometry. It is a structure that physically points toward the sun, fighting against the overwhelming flow of solar wind and light. In a standard comet, the tail is created by the heat of the sun. As the object gets close to the star, the ice on its surface turns into gas, blowing dust and particles off the surface. The pressure of sunlight and the solar wind, a stream of charged particles shooting out from the sun, pushes this dust away. Think of it like a person with long hair standing in front of a powerful fan. Their hair will always blow behind them away from the fan. This is why comet tails point away from the sun. However, this object has a distinct bright spike pointing directly into the wind. It is as if that person standing in front of the fan had their hair flying forward directly into the blast of air. Naturally, the scientific community scrambled to find a comfortable natural explanation. We do not like mysteries, we like puzzles that fit into the boxes we have already built. The first explanation proposed was an optical illusion, a phenomenon known as a projection effect. Sometimes due to the angle of the Earth relative to the comet's orbit, a curved tail can appear to point toward the Sun simply because of our line of sight. It is similar to how a straight road seems to narrow and vanish into a single point at the horizon. We spent days running simulations checking the viewing angles and calculating the orbital geometry. The computer models were run thousands of times, but the result was always the same. The geometry did not match. The angle was too sharp, the structure too defined. This was not a trick of the eye, it was a physical reality. So we moved to the second explanation, heavy dust fallback. In some rare cases, comets release particles that are very large and heavy pebbles rather than dust. These heavy pieces are not easily pushed by sunlight. Instead, they stay in the comet's orbit, trailing behind it like breadcrumbs. If the viewing angle is right, this trail of heavy debris can look like a spike pointing toward the Sun, but this theory collapsed under scrutiny as well. Spectral analysis, which allows us to read the chemical composition of an object by the light it reflects, showed that the material in the tail was not made of heavy dark rocks. It was fine, reflective, and incredibly light. According to the laws of physics, material this light should be blown backward instantly. It should not be able to hold its position against the solar wind. The third attempt to explain this involved aerodynamics and magnetic fields. We hypothesized that perhaps the object was interacting with the Sun's magnetic field lines. If the dust were electrically charged, it might be guided by magnetic forces rather than just light pressure. This happens with solar prominences and plasma. But for this to work, the cloud around the object would need to be highly ionized, stripped of electrons, and electrically active. The data, however, showed the opposite. The cloud was neutral. It was cold. It had no business reacting to magnetic fields in such a strong, organized way. Every natural model we applied was like trying to fit a square peg into a round hole. The peg would not fit no matter how hard we pushed. This failure brings us to a necessary comparison with the two great interstellar visitors that came before. First there was Oumuamua. It was the ghost. It was long, thin, and tumbled through space. It accelerated as it left the solar system, pushing itself faster than gravity allowed, yet it had no visible tail. It had the motion of a comet, but the look of an asteroid. We explained it away by saying it was outgassing hydrogen, a fuel we could not see. Then came Borisov. It was the Comfort. It looked exactly like a normal comet from our own system. It had a tail, it had a coma, and it behaved exactly as our equations predicted. Borisov lulled us into a false sense of security. It told us that interstellar objects were nothing to fear, that they were just rocks from other stars. But this new visitor breaks the pattern established by both. It breaks what we might call the rule of number 3. In science, and often in cognition, we rely on a set of 3 assumptions when we see something moving in the sky. Assumption 1, it is moving because of gravity. Assumption 2, if it changes speed, it is because of heat-releasing gas propulsion. Assumption 3, if it releases gas, the trail must follow the flow of the solar wind. Oumuamua broke assumption 2 by accelerating without a visible trail. Borisov followed all the rules. This object, however, follows the first 2 rules but shatters the third. It has a tail, so it is releasing gas. But the tail ignores the solar wind. It implies that the material coming off this object is being ejected with a force or a directionality that overcomes the natural pressure of the Sun. It suggests a focused release, a jet pointing specifically toward the star, or perhaps a shield of some kind that prevents the solar wind from blowing the material back. This brings us to a place of profound scientific humility. We are standing on the edge of what we know, looking out into a dark ocean where our maps no longer apply. The anti-solar tail is not just a weird visual feature, it is a signal that our understanding of small body physics is incomplete. Or more tantalizingly, it suggests that we are looking at something that is not purely a product of random chaotic nature. When nature fails to provide an answer, we are left with the uncomfortable possibility of the artificial. If a boat moves against the current, we assume it has an engine. If a bird flies into the wind, we know it is using energy to do so. We are looking at a celestial object flying into the wind. The explanations of magnetic fields, dust, fallback, and optical illusions were our attempt to describe this motion as a passive drifting. They have failed. We must now confront the reality that there is an active process happening on that surface. We are no longer just observers cataloguing a rock. We are witnesses to an anomaly that challenges the fundamental behavior of matter in our solar system. The impossible tail is a finger pointing at our own ignorance, reminding us that for all our telescopes and supercomputers, the universe still holds the capacity to surprise us completely. We are not the masters of this domain. We are merely watchers standing on the shore trying to understand the strange ship that has just sailed against the tide. The feeling is not fear, nor is it excitement. It is a quiet, heavy realization that the chapter we are writing now will be unlike any that came before. As the interstellar visitor began its long, silent journey back into the deep darkness of the void, it left behind something far more lingering than the data recorded on our hard drives. It left a question. It's a question that hangs heavy in the air of observatories and universities, a question that is whispered in coffee shops and debated in quiet corners of the internet. It is the question that science is often too afraid to ask, yet it is the only one that truly fits the strangeness of what we witnessed. Is it artificial? To ask this is to stand on a precipice. For decades, the search for extraterrestrial intelligence has been a fringe pursuit often relegated to science fiction or wishful thinking. Serious astronomers study rocks, gas, and gravity. They study the dead mechanics of the universe. To suggest that we have observed a piece of technology, a buoy, a probe, or a piece of debris from a distant civilization is to risk one's reputation. It invites ridicule. But the data from this object demands that we summon the courage to look at the uncomfortable possibilities. We must look at this through the lens of a famous scientific tool known as Occam's razor. Occam's razor is a principle of logic that suggests the simplest explanation is usually the correct one. When you hear hoofbeats, you should think of horses, not zebras, unless you are in Africa. In astronomy, when we see a light moving in the sky, the horse is a comet or an asteroid. These are the natural rocks of the solar system. The zebra is an alien spaceship. Therefore, logic dictates that we should assume it is a rock. However, this visitor challenges how we use the razor. To make the natural rock hypothesis work, the explanation stops being simple. Because this object did not behave like a rock. It accelerated away from the sun, but it had no tail of gas to push it. To explain this naturally, scientists had to invent complex theories. They suggested it might be made of solid hydrogen, a type of iceberg never before seen in science, which would evaporate invisibly. Later, others suggested it was a dust bunny made of loosely packed particles. These explanations are complex mental gymnastics. They require us to imagine types of matter that we have never observed existing in conditions that might not allow them to exist. Ironically, the artificial hypothesis might actually be the simpler one. If you admit the possibility that it was a light sail, a thin flat piece of technology pushed by sunlight, all the strange data suddenly fits perfectly. The acceleration, the tumble, the shape, the lack of a tail, the math works immediately. In this specific case, saying it is a machine might actually be the horse and the hydrogen iceberg is the zebra. This brings us to the bravery required in science. True science is not about confirming what we already know. It is about following the evidence wherever it leads, even if it leads to a place that frightens us. Throughout history, we have punished those who dared to suggest we are not the center of everything. When Galileo suggested the Earth revolved around the sun, it was a heresy because it made us feel less special, less central to God's plans. Today, suggesting that we are not the only intelligent builders in the universe triggers a similar defense mechanism. We want to believe we are unique, or perhaps we are terrified of the idea that we are not. If this object was artificial, it implies that the galaxy is not an empty room waiting for us to fill it. Instead, it means the galaxy is already full, and we are just waking up. We are forced to ask, are we observing geology or are we observing technology? Geology, the study of rocks and nature, tends to produce lumps. Gravity pulls things into spheres or potato shapes. Nature is chaotic and random. Technology, however, is designed. It has purpose. This object was 10 times longer than it was wide, a shape so extreme that we have never seen a natural asteroid match it. It reflected light in a way that suggested it was shiny or perhaps made of metal. It tumbled in a controlled, rhythmic way. If you walked along a beach and saw 1,000 jagged rocks, and then you found a perfectly smooth flat plastic bottle, you would not need a laboratory to tell you the difference. You would know that the bottle was made by something with a mind. We are looking at the cosmic beach, and we have found something that looks suspiciously like a bottle among the rocks. But what does this mean for us emotionally and philosophically? If we cross this threshold of belief, if we allow ourselves to accept that this might have been artificial, the feeling is overwhelming. It is a specific blend of humility and hope. On one hand, it makes us feel incredibly small. If other civilizations are building light sails that can cross the stars, they are likely far more advanced than we are. We are still struggling to send humans to Mars while they may be surfing the currents of the galaxy. We become like children playing in a sandbox, suddenly realizing that there is a vast city being built around us by adults we cannot see. But on the other hand, this is the most hopeful thought the human race could ever have. It means we are not alone in the dark. It means that life is not a fluke, a mistake, or a tragic accident that happened only once on a blue planet. It means that the universe is alive, It implies that survival is possible. If someone else survived their technological adolescence and made it to the stars, then perhaps we can too. It gives us a model to aspire to. Even if we're wrong, even if in the end it turns out to be just a very strange rock, the exercise of belief is vital. If it is just a rock, it proves that nature is far more creative and stranger than we ever imagined. It proves that the universe is still full of mysteries that our current textbooks cannot explain. It reminds us that we should not be arrogant thinking we have catalogued everything in the cosmos. The threshold of belief is not about blind faith. It is about keeping the door open. It is about looking up at the night sky and refusing to shut our eyes to the impossible. When we look at the stars now, we are not just looking at nuclear fire and cold dust. We are looking at potential. We are looking at a horizon that is wider than we ever dreamed. This visitor has passed us by, we could not catch it. We could not take a photo of its surface. But it gave us a gift. It forced us to look in the mirror and ask, are we ready to meet the others? Or are we so afraid of the answer that we will pretend everything is just a rock? To believe in the possibility is to grow up. It is the moment humanity stops staring at its feet and begins to truly scan the horizon, waiting for the next cease, and hoping that next time we will be ready to say hello. The journey has been long, and now we have arrived at the final threshold. The date on the calendar is October 29th. In the language of astronomers, this is the moment of perihelion. It is a word that sounds technical, but its meaning is simple and beautiful. It means closest to the sun. For months we have watched the great traveller move through the darkness of deep space. We watched it glide past the outer planet's silent and cold motions. We watched it grow brighter as it crossed the invisible lines of our solar system, and now it has reached the climax of its voyage. It is diving into the brilliant embrace of our star. On Earth, the mood has shifted. The anxiety and the loud debates of the early days have faded away. A strange, heavy peace has settled over the world. From the busy streets of big cities to the quiet corners of the countryside, people are simply waiting. We are looking up not with fear, but with a sense of wonder. The telescopes are all pointed toward that blinding point of light. The data streams are flowing, but for the first time the numbers do not seem to matter as much as the feeling. As the object swings around the sun, bathed in intense heat and light, we are forced to ask the final question. What is it? Is it an ancient ship sent by a distant civilization to say hello? Or is it simply a piece of rock and ice, a natural wanderer from the dawn of time? As the moment of perihelion arrives, we realize that the specific answer does not matter as much as we thought. Whether it is a machine or a mountain of ice, the result is the same. The universe has spoken to us. It has reminded us of how vast the dark ocean of space truly is, and how small our little island of Earth is in comparison. This is the great lesson of the comet. It is a lesson in humility. We often think we are the masters of everything we see. But when a visitor like this arrives glowing with the light of 1 billion years, we remember that we are just passengers. We are small, but we are together. In the face of something so massive, our differences down here on the ground seem to disappear. We are just people standing under the same sky, breathing the same air, sharing the same moment of awe. The object completes its turn, it survives the fire, it does not burn up, it glows brighter than ever before a beacon of resilience. It begins its long journey back out into the dark, heading away from us, returning to the silence of the outer void. It leaves us behind, but it leaves us changed. We are a little quieter now. We are a little more thankful for the warmth of our sun and the safety of our blue world. And now the story is over. The telescopes are turning off, the lights in the observatories are dimming, the excitement is fading into a soft, comfortable memory. It is time for you to turn away from the sky and look inward. It is time to find your own perihelion, your own center of warmth and peace. Close your eyes, let the image of the bright sun fade from your mind. Imagine instead a soft, velvet darkness. It is not a scary darkness, it is the comforting darkness of a safe, warm room. It is the darkness of sleep waiting to wrap around you like a heavy, soft blanket. Take a deep breath in, inhale slowly, and now let it out, exhale completely. With that breath, let go of the story, let go of the questions, let go of the need to know the answers. The universe will keep spinning without your help tonight. You are free to rest. Imagine you are floating in that vast, quiet space we talked about. But here there is no cold. There is only a gentle warmth, like the feeling of the sun on your skin on a perfect spring afternoon. Feel that warmth touching the top of your head. It is a relaxing, tingling sensation. It tells your muscles to soften. The tension in your forehead melts away like ice turning to water. The little muscles around your eyes relax. Your jaw loosens. Let go! Feel the wave of relaxation move down your neck and into your shoulders. We carry so much weight on our shoulders, but here in this quiet space there is no gravity. You are weightless. Your shoulders drop down away from your ears. They feel heavy and loose. The warmth flows down your arms, past your elbows, all the way to your wrists and hands. Your fingers curl naturally soft and still. There is nothing left to hold on to. You have done enough for today. Breathe. The gentle feeling moves into your chest and your stomach. Feel your breath rising and falling, rhythmic and slow. It is like the tide of a calm ocean, rising and falling, rising and falling. With every exhale, you sink deeper into your bed. The mattress supports you completely. You're safe. Now feel the relaxation flow down into your legs, past your hips, past your knees, down to your ankles. Your legs feel heavy, pleasantly heavy. They are sinking into the mattress. The warmth reaches your toes. Your whole body is now a single field of peace. You are glowing with a soft inner light, just like the traveler in the sky. Everything is slow, everything is quiet, everything is exactly as it should be. Imagine the comet one last time, but now it is far away. It is just a tiny speck of light, drifting silently into the deep, peaceful dark. It is sailing into the night, and you are sailing with it, drifting, floating, gliding into the silence. There are no more words. There is only the soft rhythm of your breathing and the heavy comfort of sleep. The stars are watching over you. The universe is holding you. Good night.